Hello friends, in today's class we will proceed further with our discussion with reliability. So, in the previous class I tried to explain the concept of reliability from the general point of view like consistency point of view. Also I tried to explain the concept from the statistical point of view by using the true score theory or classical test theory. So, in this class we will discuss further about the different types of reliability in case of the social science research or measurement in the social science field. So, again to remind you, reliability means it is the consistency of scores or measurement in terms of reproducibility of the scores. Okay. Secondly, it also means that it is the relative absence of the errors in the measurement of a measuring instrument. Okay. So, now coming to the type of reliability, okay, the first type of reliability is the test retest reliability. So, test retest reliability, as the name is indicating, that means by using a measuring instrument, okay, or a measuring instrument is tested on a particular group of people or group of student or a sample, okay, at a point of time. Now, that similar test or equivalent test or equivalent instrument may be measured after a time gap on the same group of sample, means the testing the instrument in a two occasions. That is why this particular type of reliability is also known as, that coefficient you get from this particular reliability testing is also known as the temporal stability reliability or coefficient of temporal stability. Like you take the example of the test, knowledge test. Okay. So, the purpose of the using the knowledge test is to maybe find out the achievement of the student or maybe find out the knowledge of the student. So, now you designed an instrument, you design a class test, okay, you find out what is the knowledge level of the students. Okay. Now, in this particular example, in case of knowledge test, okay, it is not possible to use the same instrument because the respondent already know about this particular answer of the question. Okay. But in this case, okay, you can use the equivalent instrument, okay, because in just you think about the mathematics, to know the knowledge of a particular student maybe in algebra, okay, numerous thousands of question can be devised. Okay. So, you develop a new set of question which is equivalent of the previous one in terms of the number of question, in terms of difficulty, okay, and again you test the knowledge of the students, okay, and you set a almost similar rank among them. So, now in these particular cases, okay, reliability does not mean that they will, maybe there are 5 students, okay, in the first test they get 90, 80, 70, 65, 60. Okay. So, now reliability of the knowledge test does not mean that the second test also they will get the exact same score, but if the scores, okay, if the rank get from the scores, okay, like A got 90 in the first test, okay, so maybe in the second test he or she may get more than 90 or less than that, okay, but almost there they have the similar rank, like A was the first ranker, B was the second ranker, okay, in the first test and the second test A was the first ranker, B was the second ranker, maybe C is not the third ranker, but C is in the fourth rank. Okay. So, almost equivalent rank you get, then it is you can tell that the knowledge test is a reliable instrument to find out the knowledge of the respondent. Okay. Now, again I am repeating. So, when you are testing the reliability of an instrument, okay, we are not actually, it is not possible to testing the reliability directly. Okay. So, you remember the true score theory we talk about. Okay. So, the observed score is, or the score a particular student get, that is comprised of the true score and the error score. Now, both of this true score and error score are not visible to any observer. Okay. So, that means, okay, so reliability is the proportion of the true score. So, that means you have to derive reliability from the other phenomena. Okay. Now, here in case of testing a reliability of the instrument, we depend on the respondent or the response pattern of the respondent. So, when you are talking about the reliability of the instrument, actually you are talking about the response that particular instrument generated among the respondent. Okay. So, now how to carry out this test retest reliability? Okay. So, here what you do, okay, you generally use the same form of the question with the same sample. There another particular thing you have to keep into your mind when you are using the test retest reliability, that is the difference, time differences. Generally, if there is the larger time difference, there will be the less reliability, or the coefficient you calculate, that will be much lesser. If the time difference is smaller, like today you conducted the test, in the next day you again you conduct. Okay, so there is a much chance of the higher score, okay, or the similar score. Okay, so that is why time difference is important. In generally in the social sciences, for testing the reliability of instrument, we give a time difference between the 2 week or like 15 days, a fortnight is an quite acceptable general time duration. Now, after finding this two set of score, what you do, you simply calculate the correlation coefficient between them. So that is why as a method you can use the Pearson correlation coefficient, or maybe you can depend on the different graphs, like you can develop a scatter plot, and if you look into whether the score are they are close to each other or not. Okay, by looking into that you can find out that whether the test retest reliability is satisfied or not. Okay. Now, next type of reliability is the internal consistency reliability. So, what it is? It is the consistency of people's response across the item on a multiple item measure. So, for a recap, I already told you that classical test theory, assuming that and also the target of the social scientific research, okay, that required that a generally instrument is comprised of a number of items, a number of questions. Okay. So, for the better understanding, we will take it as a number of statement, number of question. Okay. So, it generally use the interchangeably, terms are used. So, now, and these questions, why they are designed? They are designed to measure one particular single construct or one particular single concept. Okay. So, that means all the terms or all the items or all the question you are putting in a measuring instrument, okay, they are supposed to relate to each other. Okay. So, that is the point of the internal consistency. Okay. So, internal consistency means, okay, whether the people's response are similar, okay, in a set of items which are supposed to or directed towards measuring a single concept or construct. How to measure what are the methods to find out the internal consistency reliability. Okay. So, there are 4 popular method. Okay. So, one is average inter-item correlation, second is average item total correlation, or you can use much better method like split up method and convex alpha. Okay. So, what is average item inter-item correlation? So, now if you can calculate the response, okay, of all the respondent, okay, and if you can calculate the correlation between each and correlation between the items response, that means if the items are similar, okay, so there the response pattern of the respondent will be the similar. Okay. So, that can be find out by finding the inter-item correlation. Okay. So, if you put a matrix, okay, so if there is an 6 item, so there is how many combination is possible? It will be around, it is the formula is n into n minus 1 by 2, that means it is 6 into 5 by 2, 15 possible pair is possible. Okay. So, 15 possible, like the item 1, okay, what is association in the based on the response to the item 2, item 3, item 4. Now, if you take the average of it, okay, you can find out the average inter-item correlation. So, that is, if it is high, that means the response pattern in all the items are consistent. Okay. So, that is the indicator of this average this internal consistency reliability. Second one, what you can do? You can use the average item total correlation. So, what you do here? So, here you basically add another particular variable. So, apart from the 15 pair I talked about, okay, so you add the total score of the people of the total correlation, okay, in each of the item. Okay. So, as in the 7th variable or 7th row here or 7th item here, then you can go for the calculating the average correlation coefficient. Okay. So, that we call the average item total correlation. So, it will be much more clear. Okay. So, when we will in the subsequent class we will look into how to do it in the popular software like Excel. Okay. Now, I told the second, these are the first 2 methods. Okay. What are the other methods available? Okay. So, there is split up method and there is convex alpha. So, what split up method is talking about? Okay. So, split up method is talking about that it is about dividing the test into 2 equivalent form. Okay. So, now, so as that all the tests are all the items are measuring the same construct. Okay. So, that means okay, if you make a two separate hop out of the whole test, okay, so they will also have the response pattern, or they will also have the similar or high correlation. Okay. That means the response pattern of the respondent in the two half of the same test will be similar. Okay. So, that method we call the split half method. Okay. That means if you have a 6 item, okay, you make them the two equal half, and you calculate the correlation coefficient between them. Okay. So, that is the another form, or which is known as the split half method. Okay. So, split half method, sometimes it is known in names of the Spearman-Brown internal consistency reliability method. Okay. So, Spearman-Brown, it is not the actual method. Okay. It is the correction which you need, because you are actually reducing the test into two smaller half. Okay. So, Spearman-Brown actually provided the correction formula when you calculate the correlation coefficient based on by halving a particular test. Okay. And last one is the Convac alpha. So, Convac alpha is if you are using any statistical software, you will find this Convac alpha option for the internal consistency correlation or internal consistency reliability. Okay. So, now in this Convac alpha, for simple understanding, okay, it is like that, like you take for making the two half and the split half method, okay, you take a combination of the items. Okay. So, now just you think, okay, you calculate one split half, again you start with all of the methods, all of the items, and you randomly selected another half. Okay. So, the second group of items means second half you are choosing, okay, or second time you are doing the split half, the two half may be different. Okay. So, now if you consider all the possible combination of the split half which is possible by all the items, taking the different combination of the items, okay, if you mathematically calculate that correlation, that is basically the Convac alpha. So, Convac alpha is mathematically equivalent to the all possible combination in a split half reliability calculating technique. Okay. Now, one of the most popular method or mostly used method of this reliability calculation is the split half method. Okay. So, but for using this particular method, you have to keep certain limitation of it into mind. Also, what are the advantage of using this method, we will look into that particular aspect. Okay. The first thing is that for using the split half method, the number of questions should be more, at least, okay, the question this particular test should have more than 10 items. Okay. And secondly, all the items or all the question, okay, in a survey, in a particular measuring instrument, okay, they must measure the same construct or same knowledge area. Okay. If it is not, if the construct is multidimensional in nature, means there are clear cut different aspect of the concept, this particular construct, then the split half method may not be well suitable. So, how to do that? Split half method along with the Spearman, when you are using the Spearman-Brown formula. Okay. First, you have to divide the test into two equal halves. Okay. So, generally it is an accepted rules that, okay, we take the odd numbers of item together and now even number of item together. Okay. Then calculate the scores of each half by summing the score, means all the score in a particular, maybe in the test comprised of the 4 items. So, the first and third will be together, 2 and 4th will be together. So, we will calculate the sum of the response received by each of the item from the respondent. Okay. Then we will go for the calculation of the correlation coefficient between the score of the two halves. Okay. And as we are calculating the correlation coefficient by reducing the number or only based on the half test, okay, so you need some correction method. So, here came the role of the Spearman-Brown prophecy formula, okay, which basically correct the split half correlation coefficient you get from the half test, okay, and it adjusts for the full length test. Okay. Now, it is looking like little bit theoretical, we will try to do it in some subsequent class in the Excel. Okay. Now, this split half reliability, though I tell you that this is mostly used method for the reliability calculation after Convac alpha, okay, or if you take the Convac alpha is a special case of this split half reliability of the split half method of the internal consistency reliability, but you have to keep into the mind the split half method of reliability calculation has a number of limitation. Okay. So, first limitation is that it does not capture the full range of sources of measurement error or variability in the data. Okay. So, this difference in the test code may come from the many other sources. So, generally the split up does not have the ability to consider all this particular problem. That is why it is only a limited assessment of the reliability. Second is that it depends on the item composition. Okay. So, the estimate obtained through the split hub analysis can only depend on the how the items are split into hubs. So, that is why there is a method of the Cronbach alpha. So, that means in the split hub method only one combination of the items is taken into consideration. So, how about the other possible combination? Okay. So, that is the second limitation. Third one is that the split hub method again susceptible to the item order effect. Okay. So, basic assumption of using the split hub method is that item how they are ordered, they does not actually affect the systematically influence the response, but it may not be actually true in the all of the cases. Like just you think about your experience with the multiple test or maybe an competitive exam or maybe an class exam, where maybe the first few questions were very difficult and you were unable to answer. Okay. So, that actually ruin your whole test, okay, ruin your whole day. Okay. So, that means that difficulty or how the item are ordered, they may have certain effect on the response. Okay. So, split up generally assume that it does not have any effect or it does not have any systematic influence on the response pattern of the respondent. Okay. And limited generalizability, Okay. So, the reliability estimate you obtain from the split up may not be representative of the scale reliability on the other split. I already told that it is only taken into consideration only one split. Okay. And also the split up is also sensitive to the scale length. Okay. So, longer if you have a longer scale, then it have a generally higher, you will get a higher reliability coefficient by using the split up method. If the scale length is much smaller, so generally you get a smaller coefficient through the using of the split up method. And last one is the assumption of the equivalent half. Okay. So, if you are not using randomization, because I told that in case of Spearman-Brown formula, we generally how we make this equal half, okay, by selecting the odd number of item together and even number of item together. Okay. So, when you are not using this random selection of the items and you are not again assigning this item randomly to your subject. Okay. So, you cannot assume that this both of the half are equivalent. Okay. So, that actually affect the reliability coefficient you get from the Splitman reliability method. Okay. So, another way of calculating this Splitman reliability coefficient is this Goodman split up formula. Okay. So, again this Goodman formula, it basically depend on the Spearman-Brown formula for its calculation. Okay. I presented the this Goodman split up reliability coefficient here, okay, which is 2 into Spearman-Brown coefficient divided by 1 plus Spearman-Brown coefficient into the k minus 1. Okay. So, we will do it in the next class in the Excel, or we will try to do it in the practically. Okay. So, the Goodman's reliability is generally comprised of the 6 lambda. Okay. Among them, this lambda 2 and 4, it is directly comparable with the split up reliability. Okay. And the 1, 3, 5 and 6, okay, that is basically used for the internal consistency, but not directly equivalent to this. Okay. Now, Goodman, though it is used in the lesser extent in the test, okay, or in actual testing of the reliability, but it also have a number of advantage and limitation. Okay. So, what are the advantages? Okay. So, it is the sensitivity to unidimensionality, means this Goodman reliability testing, they generally perform well. Okay. So, when the scale items are the highly correlated, means they are unidimensional in nature, or they are indicating towards the single dimension. Okay. Secondly, Goodman lambda, okay, they can handle both the binary item as well as they can handle the item which is polytomous in nature, okay, means which are ordinal in nature. Okay. And also it is very robust to the assumption of the violation. I already talk about the different assumption which are there under the split up method. Okay. So, this Goodman alpha is much more robust to this violation of this particular assumption. Okay. So, these are the 3 advantages. And what are the limitation? The firstly, its sensitivity to the local dependence. Okay. When the 2 or more item are highly relevant or they share the context, okay, so this can actually inflate the Goodman lambda. Secondly, again it have the limited generalizability. Okay. So, this unidimensionality which is advantage in the one hand, okay, it may be, and problem or limitation to the other hand. If the construct is much broader in nature, okay, say Goodman lambda, maybe the score may be much lower. Okay. And thirdly, okay, so it does not provide you with single reliability coefficient. It generally provide Goodman lambda is not easy to understand or prone to easy understanding like the your Spearman Brown formula or the even you got to get from that retest reliability method. Okay. So, coming to the next type of the reliability, that is the inter-rater reliability. So, if you remember, many times I discussed about that in the social sciences, one of the problem is the number of observer engaged in the data collection, or maybe the change that is because human observer is always involved in the interpretation or the collection of the information in the social science. Okay. So, there is always chance for the human bias. Okay. So, inter-rater observability is particularly important, okay, in the research project on the all the research studies where a number of judges basically or number of observer or interviewer basically engaged in the data collection process. So, inter-rater reliability simply means, okay, how the different observer they are consistent with their judgment. Okay. Maybe I am using a particular scale and I am trying to look into I am trying to judge a particular student. Okay. How much honest he is, how much sincere he is. Okay. So, now another teacher also using the same instrument, he is also judging the same parameter. If we using the same instrument, if we our findings or our observation are almost similar, then we can tell that this inter-rater reliability is much higher. So, this parallel form reliability, which is another type. Okay. So, it is basically getting the same or similar result when you are using the two equivalent instrument, okay, on the same sample. Okay. So, that is sometimes it is used, okay, where the you cannot use the single test, okay, the two of the times. Okay. So, it can also be calculated. Now, both this internal consistency reliability as well as this parallel form reliability, okay, they are not very good for the when the construct is much broader in nature. Okay. Much broader in nature means it is sometimes possible also, because in social science the construct you are basically we generally deal with the construct and construct are not so much clear cut or sometimes they are not actually unidimensional also. So, in that cases this parallel form reliability or internal consistency reliability may not be an suitable instrument for calculating reliability of an instrument. Okay. So, this thing you have to keep into the mind. Okay. One last type of the reliability is the known as the rational equivalence reliability. Okay. So, this particular formula was developed because of this problem or limitation of the internal consistency reliability. Okay. So, this KR20, which is this particular rational equivalence is better known as. Okay. So, it is reliability for the dichotomous item by considering all the limitation we talk about or some of the limitation we talk about in item in split up method of the reliability. Okay. So, that is item difficulty, spread of the test, length of the examination. Okay. So, those may actually affect the split up reliability. Already we discussed it as a part of the limitation of this method. Okay. KR20 was developed for by taking into consideration these all these aspect. Okay. But this is suitable for the dichotomous item, means where that this answer of the question is in the basically yes or no or in the two particular binary two form. Okay. So, now talking about the benchmark of the reliability. Okay. So, reliability coefficient is basically a type of the correlation coefficient. So, if your instrument the respondent based on the responses your instrument you can get the reliability coefficient of the more than 0.80, then you can take that your instrument is reliable enough. Okay. So, up to 0.7 to 7.9, okay, that means okay, it is adequate, may not be, you may not need to change the or improve your instrument, but you have to mention that there is certain limitation, okay, or in the reliability there is a question mark. But if it came down below 7.0, then there is a need for the change in the question in the which to be included into the measurement instrument. Okay. So, now in the some succeeding class I will show you. So, there is statistical tool available which actually indicate that if you exclude this particular item, what change will happen into the overall reliability of your particular measuring instrument. We will complete or we will conclude today's lecture with this some tips or something or some particular point you have to keep into the mind, okay, about improving the reliability of your particular measuring instrument. Okay. The first part is that you have to write the items, or here items means the question of the which are the part of the measuring instrument. Okay. So, that should be written unambiguously, means they should be clear cut, simple words, using simple words and the clear cut way. Okay. Floweristic word or artistic word, okay, should not be included into your measuring instrument. Okay. So, because when you are using unambiguous word, okay, so also I already talked about the different type of unambiguous question. Okay, I gave the example, okay, in the some other classes. So, when you are using this ambiguous word, so those are basically prone to the different meaning by the different respondent. So, basically in this process, okay, error generally creeps in. Okay. So, reliability means it is the relative absence of the error. Okay. Secondly, so the number of items in your instrument, that should be much larger. Okay. It is the simple formula of the statistics. Okay. So, if you increase the sample size, there will be less chance of the error, okay, by using this particular formula, okay, or particular understanding. Okay. So, there should be enough number of item in your measuring instrument. Okay. And if your instrument you find out that it is not reliable enough by after calculating the reliability, what you can do? Okay. So, you have to add on, that means you have to add the item which are equal kind and quality. Okay. So, simply if the number of items increase, the error part will come down. Okay. And to ensure the reliability of the instrument, you have to provide the clear cut instruction to the rater, or clear cut instruction for the respondent who are supposed to answer against this particular item. Okay. And the test environment, again it is a source of the potential error. The test environment should be consistent. Okay. So, that means you have to ensure that the participant get same amount of time, same setting when they are responding to that particular measuring instrument. Okay. And also the heterogeneity, or the more heterogeneous the group, there is a much more chance for the higher reliability. Okay. So, if it is homogeneous, so there is if that particular item is, they are not, or they are prone to the more bias. Okay. And last one is that is the item analysis. That means the item should be included into the scale based on the analysis of the difficulty and discriminability. Okay. Discriminability means how much a particular item can differentiate between the two person who hold the different psychological part. Okay. If it is a knowledge, okay, how much they can differentiate between the two person who maybe have low knowledge, who have the higher knowledge. And difficulty means, okay, that what should be the level of difficulty? It is whether it is very difficult for all the respondent, whether it is averagely difficult, whether based on the response pattern. Okay. So, that the average difficult item and the item which have the good discriminability, which can discriminate quite good way between the different group of the respondent, okay, those items should be included into your measuring instrument, and it ensures the reliability of your instrument. In today's class, we discussed about the different types of reliability in terms of the test-retest reliability, in terms of the split up or internal consistency reliability, in terms of the inter-rater reliability. Also, we talked about parallel form reliability and the CAR-20 or the rational equivalence reliability, and the different methods which are used to calculate this reliability, or different type of the reliability coefficient, and some general aspect which the researchers should keep into the mind to improve as well as to ensure the reliability of their instrument. Further knowledge or in-depth knowledge in this particular topic, you can follow this, always follow this textbook. Okay. So, with this we will conclude our lecture. Thank you.